Hey guys, we are going to be covering section 5.7 today, getting towards the end, pretty much the end of chapter 5, quadratics. It's a big chapter, there's a lot of stuff in it. So if you're feeling a little bit of chapter 5 fatigue, that is natural. We are almost there and we'll be talking about that at the end of this video. So 5.7 right here, analyzing graphs of quadratic functions. So we've looked at graphs a lot. We've looked at solving quadratic equations. And so right here, we've got a few different parabolas that are on the screen, red, blue, and green. And at the top there, you'll see something called vertex form. Now, this form of a quadratic equation is where we are going to be living all day today. And it's actually super useful, again, as you continue to climb the ranks in math and get to more advanced concepts. Being able to do what we're doing today is going to be really important. So first thing I would do is write down that vertex form. Y equals A times quantity x minus h squared plus k. And now that you hopefully have that written down, we're going to look over here at this table and look back at that graph. What do all those letters stand for? Well, the first thing I would mention is that h and k, the h and k in that equation, represent the vertex of the parabola. So h and k are the vertex. H is the x coordinate, k is the y coordinate. You'll also notice then that x equals h will be the equation of our axis of symmetry because it's on that x coordinate of the vertex. We've seen that before. So h and k control the vertex and the axis of symmetry where those occur on the graph. Now that also implies a couple other things. K then controls what is called the vertical translation. Vertical meaning up, down. And translation, if you remember geometry, translating figures means just moving them, not changing the shape at all, but moving them up, moving them down. And so you can see a few test cases here on this graphic on the screen right now. When k is greater than 0 in red, if k is greater than 0, that means we're moving up. Okay, if k equals 0, we're just at the origin. We're on the x-axis. We haven't moved up or down. If k is less than 0, so if k is a negative number, we move down. And so the k value controls that vertical translation. H, you might then have guessed, controls the horizontal translation. H controls, are we moving to the left or the right at all of our starting point, traditionally the origin. So you can see in green when h is less than 0, when it's a negative number, we move left. When h is greater than 0, in red, we move right. And then when h equals 0, we're not moving left or right from that origin. We are kind of just staying right there horizontally. Now, then the other one that we haven't talked about is A. That's the other variable that we haven't really mentioned. And A concerns itself with the direction of opening and the shape of the parabola. So direction of opening we've kind of talked about. If A is a positive number, we're opening up. If A is a negative number, we're opening down. That still stays the same. But then check out what it says here kind of on the right. It says if the absolute value of A is greater than 1. And I'm going to phrase this a little bit differently. I'm going to say that the more positive or the more negative A gets, the steeper and skinnier the parabola gets. So for example, blue is our starting point. Blue, y equals x squared, just 1x squared. So it's a nice, typical, it's not too skinny, it's not too wide parabola. Maybe the red one is y equals 2x squared, let's say. It got more positive. I'm going to add a y equals 4x squared. And that one would be super steep, super skinny there. So the more positive it gets, the steeper it gets. But the same can be said in the negative direction, because I'm going to try to draw about, let me get that second half a little bit better. This is about y equals negative x squared. It's still just 1x squared, but it's negative, so it's facing down. Well, that means that using the same color, y equals negative 4x squared would still be super skinny and super steep. It's just facing down, right? It's just facing the other direction. So the more positive or the more negative something gets, the a value gets, the steeper it is. And then on the flip side of the coin, if you take a look at green, green could be like y equals 1/2 x squared. It's still positive, it's still opening up, but that a value is less than 1. It's pretty low, which means it's going to be a super gradual parabola. I could draw one even more gradual, something like this, that just takes forever to get going. And maybe this is y equals 1/3 x squared. I don't know. But, excuse me, negative, because it's facing down, isn't it? So y equals negative 1/3 x squared. The point being, though, negative just means it's going down, and then 1/3 just means it's going to be gradual. Very, very gradual. So knowing these things about the shape and the direction of opening of the parabola, I'm going to come back to this graphic and then we're going to dive into some problems. You can see in this graphic, kind of on the left side of the screen, red is our starting point, y equals x squared. It's at the origin, it's facing up, it's not skinny, but it's not wide, it's just our standard. You'll notice y equals x squared plus 2. Well, that k value is that plus 2, which means it moved up 2 units from the origin. And that's why its vertex is 2 units up here. If you look at green, y equals x minus 3 quantity squared. And looking in here, that x minus h squared, that means h is 3. It moved 3 to the right. So we can kind of move these parabolas around. And I'm going to just make one up really quick. I will go, maybe I will graph y equals negative 1/2 x squared. So that will look something like this. 3, 4, 1, 2, 3, 4. Negative 1/2 x squared would look something like that. It's negative, it's facing down, it's negative 1/2, so it's super wide and gradual. And so we can start to identify just from the equation, what will these parabolas look like? Are they facing up? Are they facing down? Where's their vertex? Are they super skinny, super wide? And so let's do that right now. If we're given this equation, and it's in vertex form, y equals negative 3 x plus 2 squared minus 4, then we can actually tell it's going to face down, right? Because it's a negative a value. So because that a value is negative right here, we've already talked about this, we're going to have negative x squareds, meaning we know it's going to point down. What else do we know though? So we know it opens down. We know the vertex. Actually, we know the vertex because remember in vertex form, y equals a times x minus h squared plus k. Now, we're going to have to do just a tiny bit of work to line this up. A is clearly negative 3. I don't want to erase my highlighting, but my pen's not really erasing anything right now. Okay. So we know that a is negative 3. I'll kind of list that out below. What is h? Well, h, we're told, is whatever's in there with the x inside the squared quantity, but in the form it's x minus h squared, and here we have x plus 2 squared. So what does that mean? That means h is negative 2. I'm going to give you 2 ways to see this and know this. First way is just from the equation. If we plug negative 2 in, we get x minus negative 2 squared. That could be written, as we know, as x plus 2 squared. So if it's a plus with the h value, we remember we just got to flip it. How I like to think of it, though, is my h value is whatever I need to plug in to make the squared part 0. So I'm just looking at the squared part, and it's x plus 2. And so what should I plug in to make it 0? I should plug in a -2. That's my h. The k value is just whatever we see on the outside. Again, it says +4. And if you're kind of not happy with that -4 we have, remember, we could just say plus -4. So k is whatever we see on the outside here, outside the equation. So we have our a, our h, our k. So I'm going to say then that the vertex is at -2, comma, -4. Because my vertex is my h comma k value. That also means I can see how this was translated. It looks like the horizontal translation, it was translated to left, and that's why the x-coordinate of my vertex is now at -2 and 4 down. So those are kind of my translations here. I'll label those real quick. Translations. We went 2 left, 4 down from the origin. We know it's opening down, and we also know that it's going to be kind of a skinny, steep parabola. If I were just totally guessing, here's kind of what I would expect. I would expect 2 left, 4 down. I should have drawn this higher, excuse me, I'll fix that. 2 left, 4 down. So that's my vertex. 1, 2, 1, 2, 3, 4. Again, we went 2 left, 4 down. That's how it was translated from the origin. And I know it's facing down, and I know it's going to be pretty steep because it was that -3 for the A. Something like that. It's not going to be a wide one at all. But just by looking at the equation and knowing vertex form, we actually have a lot of information we can glean from this. So let's go right over here now and say if that form of the equation, if vertex form is so good, how do we get any equation into vertex form? And you guessed it, you can see it on the screen. We are going to complete the square. If it's written in kind of that standard general form, we're going to complete the square. So we practiced that in 5.5. Take a look and let's see where this gets us. We've got y equals 2x squared plus 12x minus 20. First thing I do, kind of like completing the square, I'm just going to toss that 20 over to the other side. We're getting rid of the c value just like we did in 5.5. So what else did we do in 5.5? We said we couldn't complete the square really. We couldn't use this strategy for now unless it was just 1x squared. So here's what I'm going to do. Y plus 20 equals 2 times x squared plus 6x. I'm going to pull that 2 out just like we did in 5.5. Now we have just x squared in there. And so I'm going to say y plus 20 equals 2. Oop, I'm going to leave some space, kind of like I did in 5.5. Because I know I'm going to be adding something to both sides to complete that square. So looking on the right, we kind of did this a lot in section 5.5. We said, okay, so b over 2 squared is what I need to add. So 6 over 2 squared, 3 squared is 9. I need to add 9 to that side. Now here's where things get a tiny, tiny bit different from 5.5. I didn't really add 9 to the right-hand side. I actually added 18. Because I put the 9 in a spot, I just wrote out a 9, magically, inside parentheses that were being multiplied by the 2. So that's probably the #1 thing to watch out for is, sure, we introduced 9 to the right-hand side and we wrote it out, but really we were introducing 18 to the right-hand side of the equation. We need to introduce 18 to the left to keep things balanced. So what does that do for us? Well, now y plus 20 plus 18 is y plus 38 equals 2 times, and let's write our perfect square. X, and if you did the 5.5 homework, hopefully you're saying, okay, that's x plus 3. remember that number in there is whatever b over 2 comes out to be. If you can't find it just factoring. So 2 times x plus 3 squared. And then just like magic, our vertex form is going to pop out as soon as we move that 38 over. 2 times x plus 3 squared minus 38. This is the exact same parabola, just written in vertex form. So we complete the square because we have to complete the square, right? We have x plus 3 squared. We need an x minus h squared. So now let's analyze it. Now that we have it written in vertex form, what is the vertex? Well, remember the vertex is the h comma k. It's whatever makes the inside, the squared portion, whatever makes it 0. So that's going to be negative 3 here to balance out that plus 3. And whatever we see as the k, which is just negative 38. I now know where the vertex is. I also know that the axis of symmetry is x equals negative 3 because it's always whatever vertical line goes through the vertex. Vertex was at negative 3, so that's where the axis of symmetry is. Does this open up or down? Well, a is positive. We have positive x squareds. We know this opens up. And how is it translated from the origin? Well, it looks like we went 3 left and 38 down. 3 left, 38 down. That's what will move the vertex from 0, 0 to negative 3 comma negative 38. It opens up because we had positive a's. We could also kind of go one step further and say this is going to be kind of a steep parabola because 2x squared, so that's more than our typical 1x squared. So it's going to be kind of steep, opens up. There's our vertex, there's our axis of symmetry. Let's do another one. Y equals x squared minus 8x plus 21. So nothing, well, first I'll pull the 21 over. But there's nothing really to pull out because it was just 1x squared from the get-go. So I'm adding in my plus blanks. I'm going to say x squared minus 8x, and you might be able to see that this is just going to be 16. If not, you can always do b over 2 squared. So b over 2 squared equals negative 4 squared, which equals 16. So I really did just add 16 on the right-hand side. It wasn't inside any parentheses. So I'm going to say that means we have y minus, I don't need parentheses there, sorry, y minus 5, combining those like terms, equals x, and then what goes in there if you're still kind of struggling with the factoring, x minus 4 squared. Y equals x minus 4 squared plus 5. Where is our a value? That's something people often ask. They say, where's our a value? We don't have an a value. Well, we do. It's just that invisible 1. It's 1 times that thing squared. So a is 1, so width-wise, it'll be kind of our standard parabola. It won't be super skinny or super wide. It's just normal. What is our vertex? Our vertex is going to be, so it looks like positive 4, because whatever would make our squared part 0, and positive 5, our k value that's on the end there. Axis of symmetry, x equals 4, because that's what goes through, that's the vertical line that goes through my vertex. Definitely opens up, because we had just positive x squared there. So opens up. And how did we get to where our vertex is from the origin? It looks like we went 4 right and 5 up. So again, why do we like this vertex form? Because as soon as we put it in vertex form, we actually know quite a bit about what it will look like. We know where its vertex is. That's why it's called vertex form. We know if it opens up or down. We can tell if it's going to be kind of skinnier than normal or wider than normal. Talk about those translations, axis of symmetry, things like that. So a couple other things here. can we write an equation in vertex form if we're just given this graph? And the answer is yes. As long as we have two really important pieces of information. So take a look at this problem. We've got, looks like the vertex is marked as -1, 4. And we're given this other point, 2, 1. We'll get to that. But we know that our vertex form is y equals a times x minus h squared plus k, right? We need to find values to fill in a, h, and k. And the good news is 2/3 of that is already done. We know that h is -1, and we know that k is +4. So just from the vertex, we found our h and k. Now all we need to do is find an a value. How are we going to find that a value? Using this other point. This other point is a point on the parabola, which means the equation we write for the parabola has to work for this point. So I'm going to plug this in. I'm going to plug in 1 for y. That's a really thick y. I'm going to plug in 1 for y, 2 for x, and then write the rest of my equation. And we're going to figure out what a value would make this true. So 1 equals a times, it looks like 3 in there. So 3 squared plus 4. 1 equals, so that's going to be 9a plus 4. We could subtract the 4 to the left. -3 equals 9a. Divide both sides by 9 and simplify the fraction. It looks like a equals -1/3. So we were saying that all we had to do was find h, k, and a, and it looks like we've done that now. Y equals a was -1/3, x minus my h value, which was -1, squared plus k, and the k value we found from the vertex was 4. So if you're given a graph, you need two things to be able to write an equation in vertex form from that graph. You need the vertex, h, k, that gets 2 of our missing pieces. And then if we have just one other point, we can plug it in for x and y to solve for the a variable, okay? I'd like you to try this one. Pause the video if that last one made sense. If not, go back, rewatch it, watch those couple minutes. Try this one, pause the video, and see what you get as your vertex form equation for this parabola. I'm going to pause my video, work it out, and then we'll both hit play and kind of be able to compare notes. All right, my work should have just appeared on the screen. Following the exact same procedure that I did last time, we've got this y equals a times x minus h squared plus k, the vertex form we're looking for. That vertex 3, -2, we can just plug in for h and k. And then we can plug in that other point on the parabola, 5, 3, to find our a value. A comes out to be 5/4, it looks like, meaning our equation on the right-hand side there, y equals 5/4 times x minus 3 squared minus 2. Compare my work to yours, see if it matches. Guys, this is 5.7. It's all about vertex form. And so being able to analyze equations in vertex form and see what do we know about their graphs, or from a graph be able to write something in vertex form. This will really pay dividends, and we're using completing the square from 5.5 as promised. But if we can get good at this, if we can get good at kind of analyzing these graphs, we'll really pay dividends later. So I'm going to pause right there and just call that it for 5.7. Take a look at the practice problems assigned. Let me know if you have questions so that I can clear those up. Otherwise, I will see you next time.